Hello guys, it's Felix here and welcome to my channel. So in this tutorial we are going to learn how we can use hand gestures to control the brightness of our computer screen. So as shown on the screen, you can see by decreasing the length between these two fingers, our computer screen brightness increase and decrease drastically. So you can just see it at the corner. When I increase it to 100%, it's also 100%. When I decrease it, it also decreases. And we also have the bar showing it on our screen and the percentage as well. So this is what we are going to learn in this tutorial. Stay along and let's learn together, because we are going to be building this from scratch. So let's get started and see how we can do something like this. Alright guys, so as usual, before we begin, the code we'll be writing in this tutorial will be on GitHub. So I'll put the link in the description so that if you want to play with it, you can go ahead and download it and work with it. You can advance it, and that's up to you to use it in your own case. So let's get started by importing our libraries we will need. I think we'll be using 4 libraries, so I'll go ahead and import them and I'll tell you what each library will do. Alright guys, so we are done with importing our libraries, and first library here is the OPCV library. So as usual, we'll be using it to get our feed from the camera, and anything about image processing or video processing, we'll probably be using a couple of functions from the OPCV library. Then we'll also use NumPy for some mathematical operation. Then the screen brightness control library will help us to control our screen brightness using the distance between these two fingers, the thumb and the pinky finger. Then as usual, the CVZone library will help us to get our hand tracking on. So now the next step here is to get our feed from the camera, and we have done this ton of times, so I'll also go ahead and just do it as quick as possible. Okay guys, so this is the bare minimum code we need to open our webcam, and this we have done many times on this channel. So we are creating a video capture object, and in here we are specifying our camera index. So 0 will just turn on any camera hook up to it, but if you have multiple cameras and you want a particular one, then you can try 0, 1, 2, 3 and so on. Then immediately you get any camera you want, you work with that particular camera. Okay, so we are taking this in a loop, so we say while 1, which is the same as while true. We are taking our image here using the cap.read function. Then after getting it, we probably need to show it, so we are using the cv.imshow function to show it. Then for that we are wait key of 1, not 0. So I'll go ahead and run this. Alright guys, so you can see me live in the camera. Okay, so the next step now is to get our hand detected. So we'll use the CVZone library using the hand detector. We'll get our hand detected. So let me close this a little bit so that you guys can see well. Okay, so let's create a hand detector object here. So let's call this HD hand detector. Then to get the hand detected, we simply have to just write this hd.findHands. Then in here we have to pass in our image. So this is all we need to get our hand detected, but this returns two things: returns whether a hand has been found, and also returns your image with your hand detection on. So we'll take the hands and also the image back, and this is equal to. So as simple as this, you will just get your hand tracking on. Let's run this to verify. Okay guys, so I raise my hand and it's just being detected. Let's try for the left, and it's also being detected. That's fine. So we'll now continue to get the distance between these two fingers, the thumb and the pinky finger. So you have to get the distance between these two. Then based on this distance, we will control our brightness. This is very simple to do, so let's go in and get this done. Okay, so to do that, we have to first check if a hand is detected or not, because in case there is no hand detected, we don't need to find distance, which will probably give us an error or so. So we can say if there are hands detected. Okay, so if hands, then we are taking our LM list, which is the landmark list, all the points of your palm or your fingers. So we call it LM is equal to our hand that is being detected at in the 0, then in the key of this is a dictionary, so in the key of LM list, landmark list, so LM. And this is pretty much what you need to get your landmark list, so you can print it. Let's go ahead and run this now. Okay, so you can see immediately I raise my hand, we can see many points on the terminal. So based on these points, we can detect the distance between here and here by giving it their particular ID. So each point in my palm have a particular ID associated to it. If you want a tutorial on all the IDs, we can do so, but for now we'll go straight to find this ID and this ID and the distance between them. So we use a function in the CV Zone package to do that. So let's go ahead and continue. I think we can comment this now, and the next step is to get that distance. So we have a function that helps us to do that, and this function returns you with the length and also the info and your image back. So this function is hd.findDistance, and this takes the landmark list, the points at which you want to find the distance. So we have the point here and the point here, so we are going to use those points, and the one here is at index 8 and this is at index 4, I think. So we can take the landmark list at that index 4, then we slice it from 0 to 2. We'll do same for the other one, so I think it will be easy to copy this and put it here. Then instead of, okay, this should be 4, then we change this to 8 rather. The last parameter should be our image probably, because we are getting it back here. So we can go ahead to print this length, and let's see what we get when we run this. So I'll go ahead and run. Okay, so immediately I raise my hand, you can see we are getting some values. Let me raise this so that you guys can see well. I think we'll raise it here, bring this up, you can see the values coming. So you can see the values and we are getting the distance. So the values you are seeing is the length between this point and this point here. So you can see when I close it, it decreases. When I open it, it increases. So based on this value, we are going to decrease or increase our screen brightness. And as you guys know, our screen brightness is from 0 to 100, but these values are not. So we have to convert these values from whatever they are to 0 and 100. So we have to take 2 points. That means when I close it, here is about 25. So we'll take 25. Then when I open it fully, 145 to 146, 140. So we'll take 145, 25, 145. Okay, so we have to convert it to that range. and for that we use the numpy function to do that. So I think we can comment our length here, and what we'll do now is use numpy to do that. So we'll just call this one brightness level. So let's call it b level is equal to np dot interp, and this is the function we use to convert it. Let me bring this one down. Oh, sorry guys. So this takes what we want to convert, and in this case is our length. How do I spell length here? Okay, so it should be th, not ht, if I could spell that correctly. Then we want to convert it from, we said 25 to 145 or so. We'll check that up later. So I think it should be in a list. Then we want it from this range to 0 to 100, and that's the range we want. So we'll get this in that range. Print our b level now. That's the brightness level now to see. So let me run. I think this is it, but I think I can raise this up. Maybe this out of your way. You can see we are getting 80%. So when I open it widely, we got 100%, 0% here to 100%. So based on these values, we'll control our brightness. And as at now, we are getting decimal values of floating point values, so we have to convert it to integer before we use it, so that we get good precision. Because I don't think we have a brightness level to be 28.5 or so, 28.89. So if it's 28, it should be 28. So I think we can convert it to integer before we use it. We can do that on this line. B level is equal to int of the same B level, and that's all. That will be fine. Let's comment the level now. So now we have to send this value to control our brightness or our computer brightness, and that's what this library here is going to help us to do. So it's just going to help us to set our brightness whenever we open our two fingers like this. Then we just send our brightness level to our computer. So we have a function in this library that we use to set that brightness. So we have imported it as CSB. We just come here to write csv.set brightness. Then we just give it our brightness level, and that's all. So with this single line, we can be able to change our screen brightness. This will be weird when I'm doing it, but you guys have to bear with me. So let's try this out. I will quickly run this. Okay, so let's get this done. You can see when I increase, the brightness of my screen increase. When I decrease, the brightness decrease as well. Let's see, let me pull out the brightness level. This will be fine. So you can see it's just increasing and decreasing as I'm doing it. So this is working fine now, I think, but we have to display maybe a percentage bar on the screen so that we use that as our brightness, and also to show the percentage of the brightness level. So let's go ahead and do that. So I think we have to first put on a rectangle. So we say cv.rectangle our image. Then the first point, I think, was the point. We start from, let's say, 20 20 to 150. Then the second point is 85 to 400. We have to choose the color, so let's make it red. 00255. Then the thickness, you can set this to 4. Should we go ahead and show this? I think we have to do the other triangle, which will put our brightness percentage in it. So let's just copy here and put it here. But before that, we have to convert the values we are getting here, because this is from 85 to 400, no, 150 to 400. that will be the height, so we have to convert this level to that. So I think we can copy this place, Ctrl C, Ctrl V to paste, and then instead of this we can call this I think let's just call it var, but we have to initialize it here, like var is equal to 0. Then instead of var, we'll start this, we'll have to reverse this from 0 to 100 to want it to fill a triangle. So from 0 to 100 to, that should be 400 to 150. Okay, we have two of these here, we can get rid of one. 400 to 150. I think that's good. So the second rectangle will take that value, so we give it integer of our var, and I think this will be fine. And for it, you have to fill it. So to fill it, you can either write cv2.filled or -1 just to fill it. So I think we can run this one and check. Raise our hand, and you can see how nicely, so we have a bar in there that now gives us our exact brightness level. So this, I think, is beautiful and nice. So when I increase 100%, I decrease. Okay, so what we have to do now is to get our percentage written under the bar. So let's continue and do that. So for that, we'll use the cv.putText. Then the text we want to put is what? The string of our battery level, that's B level. Then we add plus the percentage sign to it. So where's the percentage sign? Here is it. Then the position, let's start this at, I think 20 will be fine. 20 to, let's say, 430, that's what I used. This should be in its own parentheses. Then our font, then I think the color should be blue. So 255,0,0 should give us blue. I think we can bring this one down so that you guys can visualize it. And then thickness of our text, let's start with 3 and see. So now let's run this to check. Alright guys, so we have it now. Okay, we have an error. Let's see this. No, module has no attribute font. Let's say simple. Okay, it should be complex, not simple. So just have to change simple to complex. So let's quickly run this again. Okay, so let's test, and you can see it's just working nice, so smoothly. When we bring it down, it goes down. When we bring it up, it goes up. So I'll quickly bring in our brightness level now, and you can see 100% means 100%. We can come down 70, 80 when we leave it, it is there. You can come up. You can see it works fine. This is very nice. So guys, this is where we'll bring it to an end. If you like this, kindly subscribe, share with your friends, and also encourage someone to learn computer vision. So thanks you for watching, and I will see you guys in the next tutorial.